The
what
frequency is constant.
hmm,
Go ahead, Thiru.
what will happen to the frequency if the intensity is changing? Like, what does intensity do to the value of f?
Nothing. Intensity or frequency are not connected to each other.
Oh,
Intensity is basically how many photons are hitting the plate. Frequency is a completely different thing. Frequency and intensity are not connected.
yeah.
Completely two different parameters. Okay, are we done writing?
Yes, sir.
Okay, Thiru, done.
Yeah.
Moving ahead. Solve this question now. That is based on what we have discussed so far. It's easy. Try. Oh, by the way, Rakin, what is monochromatic?
Um, Only one, like mono is one.
Mono is one. What is chrome? Do you know some?
Monochromatic means out of the seven,
No, no, wait. See, mono is single. What is
yeah,
chrome?
chrome is chrome.
No, chrome has a meaning. Chrome actually is connected to colors. So chroma is color. Monochrome means single color light.
Yeah,
Monochromatic
single
would
color.
mean single wavelength light. It's only
Yeah,
having
wavelength
one wavelength.
is one. Oh, right. One wavelength, similar wavelength. Correct.
Yes.
Rate of emissions of electrons is going to increase, so it's either A or D.
Yes.
Kinetic energy of the emitted electrons, there won't be any change in that.
And why?
Half
Kinetic
mv,
energy depends on what?
half mv square.
That is fine. But in that photoelectric
Ah,
equation,
equation, it depends on h into the old frequency minus the f naught.
not old. F means
F
frequency
f
of,
minus f naught, right?
so F is frequency of incident light. In this question, nothing is being done to F. Frequency is constant. And
Yeah, so constant, right?
F naught, okay, let me write. F naught depends on what? Threshold frequency.
F naught depends on the
See, it depends on the surface, metal. Which metal?
surface, metal, right?
So in this question, are we changing the metal?
Nope, intensity does not change the frequency at all.
Right. So we are focusing on kinetic energy. If your metal is not changing, your F naught doesn't change, and your F is also not changing. So there will be
Right.
no change in kinetic energy.
D is the answer, right?
And rate of emission, how is it increasing? Raken,
Rate of emission, because when you increase the intensity of the incident on the plate, more
yes,
photoelectrons are emitted from the plate.
exactly. So more intensity. Okay, let me write down this equation and write kinetic energy will not change because kinetic energy depends on only two things, F and F naught.
Okay.
Intensity increases means more electrons are emitted. Thiru, check, does this make sense?
Yes, sir.
Option D is the answer. Right. So, Rakin, done writing?
Yep.
Moving ahead. This is the second last topic for this chapter, wave particle duality. Okay, ignore this as of now. Thiru, what does this mean? Dual nature of matter.
It means the light can behave as a particle as well as a wave.
In this case, we have written matter.
This, in this case, matter has two types of, what do you say, natures. Like it has two types of different environments. It behaves
Wait,
as
wait.
two different things.
So you said light can behave as a wave as well as a particle, right?
Yeah, yeah.
Now, when we say matter, it's like any object. Any object can also behave like a wave. So this is the definition. Dual nature means any matter is any object. Any object can behave. It is already a particle. See, objects are already particles, but they can also behave like a wave. On the other hand, Chiru, what you said was also true. Light already behaves like a wave, but light can also behave as a particle.
Hmm.
So now, Thiru, can you tell me an example? Where does light behave as a particle?
In the photoelectric emission.
Exactly. Awesome. So light can behave as a particle as well as a wave. And then, okay, so Thiru, please read this out according to
Yeah. And according to a wave is associated with each moving particle, which is called matter waves.
and it has a name, de Broglie wavelength, and it is given by this formula, h upon p, where p is the momentum.
Yeah.
And this is crucial for solving A-level questions. Write this down. Okay, done. Check.
Yep.
All right. Now, Thiru, sorry, Rakin, I want you to read out the characteristics of matter wave. So go ahead. First point,
It is lighter the particle, greater the de Broglie wavelength.
wavelength. So in this formula, mass, observe mass is in the denominator. So
Right.
if your mass is lesser, lambda will be higher.
Higher.
Second point, read this, Rakin.
Faster the particle moves, the smaller is its de Broglie wavelength.
Wavelength. Same logic, speed is also in the denominator. Right? So they have inverse proportionality. Third
Right.
point, Rakin.
The Broglie wavelength of a particle independent of the charge or nature of the particle.
So in this formula, you do not have Q. So there is no charge. That's why wavelength doesn't depend on charge. Finally, fourth point, Rakin. Rakin, read the fourth
The
point.
matter wave are not electromagnetic in nature. The electromagnetic waves are produced only by charged particles.
Yes. So as of now, just keep some space for all these characteristics. Write it later on. As of now, we are moving ahead. Kiru, are you done with the formula?
Yeah.
So keep some space for these characteristics. Not very important, but later on you can write.
But I didn't understand the characteristics.
Which all the four?
Yeah.
Okay. Read out the first point, Kiru.
Lighter the particle, greater is the de Broglie wavelength.
In this particular formula, lambda is equal to h by mv. So now, Thiru, tell me, can
Acha.
I write lambda is inversely proportional to mass?
Yeah.
So lighter the particle, what will happen to wavelength?
Greater the wavelength.
Yes. And similarly, lambda is inversely proportional to speed. So faster the particle, smaller is the wavelength,
Got
isn't
it.
it?
Yeah.
Third point, check Thiru. Did you understand third point?
Independent of the charge or nature of the particle.
And why is that?
No,
Because in the formula, you do not
this
have a charge
was.
anywhere.
So what does
And
independent mean? Does it mean
independent
like it
means
does
it
not
does not
depend
depend on
depend?
charge.
Okay. Okay. And nature of the particle?
Nature is in, is it either positively charged or negatively charged?
Okay.
That's the nature of the particle. And matter waves are not electromagnetic. What does electromagnetic even mean, Thiru?
Light.
Light. So again, matter waves do not travel with the speed of light. Speed will be different. That's why in this formula, see, V is just V. V is not C.
Why is that? Because matter is a light. Oh, it's matter, not light.
Yes, it's a matter. Matter is any object.
Uh-huh.
That's it.
So even we can be also
Yes,
invisible
of course.
particle.
So exactly, that's actually a question. Let's say if somebody is walking, what is going to happen to lambda? So what is the value of h, Thiru,
That's just constant.
6.6
into
6.626 into 10
34.
raised to minus 34.
34 divided by, and let's say if somebody is moving, Rakin, what's your weight? 65, 70, how much?
85.
85 kilograms multiplied by speed. Speed of, wait, let's see, let's take how much?
10.
10. Now, just, I don't want you to calculate, just check. In
Why
the
10?
numerator, you have 10 to the power minus 34, which is incredibly small, right?
So
So
why
the
should you
wavelength is
multiply by 10?
approximately zero. So all
Oh,
the real world objects will have zero wavelength approximately. To
okay.
have a higher lambda, your mass needs to be extremely small. And that happens at atomic microscopic scale when we are dealing with electrons, protons.
Hmm.
Getting the point. That's it.
Yeah.
So that's why these characteristics are important. Okay, this is 22.3 wave particle duality. Moving ahead to the last topic. And this is, I think, the most important. Energy levels in atoms and line spectrum. Write it down.
This is in chemistry.
Yes, हाँ ये वही है chemistry वाला. So I think you're already aware of this then,
Hmm.
Thiru.
Yeah.
Rakin, you as well?
No, I'm happy.
You haven't taken chemistry?
No, sir,
No.
you should show the die. Oh, actually, he didn't do it.
I sent it to you.
No, I mean,
So,
I thought if he took chemistry and if he showed the diagram, he would have understood.
but did you go through the notes, Thiru, which I sent?
Yeah.
So explain now. What does this mean? Energy levels and what is line spectrum?
Basically, what it means that when an electron goes to like a further energy level, like if it goes further away from the nucleus, the
Mm-hmm.
energy level increases.
Mm-hmm.
And what happens is the electron is absorbing energy in order for it, and the energy is absorbed due to the photon. So it
Awesome.
absorbs the energy from the photon and it travels to a higher energy level. And if it
Perfect.
wants to go to a lower energy level, it releases energy.
Yes. Amazing. And energy in terms of photons, it will emit.
Yeah.
All right. So, Rakin, I want you to read out this sentence. Energy levels.
Energy levels in atoms. So energy levels are regions where around the nucleus in which